In this lesson, we will use the Tcpreplay utility to assess organizational security. We are in the Tcpreplay portion of the video series. This lesson is part of a video series that prepares you for the hands-on portion of the CompTIA Security Plus exam and is designed to give you hands-on experience with the exam. So what is Tcpreplay? The Tcpreplay command is a Linux tool used to replay captured traffic from a pcap file. Network engineers, security analysts, and penetration testers use Tcpreplay to test and analyze network performance or security. It is used when testing intrusion detection systems or intrusion prevention systems, evaluating network configurations, or simulating real-world traffic for troubleshooting. The command is executed in a Linux terminal, typically on a test machine, server, or network security appliance. It helps in replicating network conditions, testing security devices, and validating network performance under specific traffic loads. By using syntax like tcpreplay -i, the interface like F0, and pointing it towards a capture file or a pcap file, it sends the recorded packets through the specified network interface. The rest of the how is what this video is all about, so let's get into it. To get started, grab the companion guide from the link in the show notes below. Also, if you like this content, please make sure to subscribe to the channel so you won't miss any new videos. Okay, so we have our companion guide on the left, we have Ubuntu Linux on the right, we have Tcpreplay, so let's go ahead and follow the instructions here. So the first thing we want to do is launch a terminal on our Ubuntu machine. So I'm going to right click here, open in terminal. We can also do Ctrl-Alt-T as you know. I'll double click in the terminal to expand it to get the full screen. And I'm also going to do Ctrl++ to make the command prompt just a little bit bigger for our eyes. I see my present working directory is at the desktop because that's where I open the terminal. I want to change to my home directory, cd tilde, do a present working directory or print working directory to get that there. And we're going to clear. Okay, well, actually I need to type clear more properly. So the couple of things we want to do here is that on our setup, we have an Ubuntu machine, but we also have behind here a Kali Linux machine, which is our offensive security penetration testing box that has Tcpreplay already installed on it. The reason why I do this is I like to stack these as a deck of cards. This is what our network looks like. We have Kali Linux here, we have Ubuntu back here. But I also like to call out the install process just in case you're building your own penetration testing box on Ubuntu or any other Linux for that matter. These are Debian based commands. So I'm going to use the sudo app update. So we're going to get all the available packages. We're going to combine this into one command, and we'll also install Tcpreplay, and we'll throw the yes command for any prompts that's going to ask us if we want to proceed. So I'll hit enter. I'm prompted for my username, of course, and password because of the sudo command, and let's see how long that takes. That took about 5 seconds. Reason being is because TCP is already the newest version. So one, it was already installed and it's already up to the latest version. So that's great. So I'm going to do a couple of things here, which is I'm just going to take a look, Tcpreplay, just to make sure that it's all fine. I did Tcpreplay tac version, and I see that I have the latest version, but it already told me that anyway. I had 4.3.2. And also we have the help option, which we will see again towards the end. But just for fun, let's just take a look at that now and see tac help. And we see we have a long list of options that we can explore. We're going to just introduce the command. Okay, so let me clear the screen as we normally do. And I'm in my home directory because I see the tilde. And I want to take a look at the interfaces that are available to me. So I'm going to do a if config just to make sure we have connectivity. And on the Ubuntu side, I have the Echo November Papa 0 Sierra 3 interface. And I see my IP assignment as 172.16.1.02. Perfect. This is fantastic. If I didn't have this, I would have to get a new client, a new IP client. I could use the sudo dh client but I have that already, so no need to refresh that. And I also want to make sure I am on the Ubuntu machine, so I'm going to run neofetch. Neofetch is going to give me the information of the command. So it's going to give me information about the operating system, right? And I can install that. If you don't have it installed, you can do a sudo apt install neofetch, again, -y, or you can put the prompt in when you're prompted. This is just verifying that we have Ubuntu 20.04. It's on VirtualBox, and it gives me a little bit of information. I just rebooted, so the uptime is only 7 minutes. This is the Ubuntu machine on 172, and it's on this network side here, this diagram. I'm going to do the same thing on the Kali Linux side. So I'll come over to Kali Linux. I'm going to use Control-Alt-T in this case here to get into the terminal. We're going to make that a lot bigger with Control++ to get that a lot bigger. And I'm going to do ifconfig as well. And I see that I'm sitting on 172.16.1.103, which is this box here. And I also have an Ethernet interface of F0, Echo Tango Hotel 0. Notice it's a different name in the interface. Kali Linux uses the older format, which is fine. The reason why I call it out is when we use our commands, you need to know which one, what interface to call, literally by its name. So we just wanted to make sure that was called out. I'm going to go back to the Ubuntu side, do some housekeeping on this portion here, as well as the top portion while we're at it. Now, once again, we all clear here. I'm going to clear my command before I run tcpdump to get a couple of captures. So we know what our command looks like. I could do this a couple of ways. I can do, once again, ifconfig as we saw before, or I could do tcpdump to see all the available -d, all the available interfaces. And I see we have this interface available, the ENP0S3. Perfect. I'm going to grab this pcap command. We'll break it down on the other side in a moment. Let's just get this pop-up out of the way, and we'll go ahead and bring that command in. And it's not the right command that we want, so let's back that out. Control U, by the way, will clear your command line. I'll come over here, copy this into clipboard, copy it into clipboard as I mentioned, and now we have our command. So to do tcpdump, we're going to capture off of the interface the Echo November Papa 0 Sierra 3 interface. We're going to write it to a capture file, and we want it into super verbose mode. And this breaks it down here. We want it very wordy so we can capture everything on the screen as well. So I hit enter. It says it's listening. It tells me the link type. It's a 10 megabit Ethernet connection, and it's waiting and listening. So we now need to capture or generate some traffic. So we're capturing traffic on the Ubuntu machine. We're moving over, generating onto the Kali Linux side. Now, once again, we saw that when we did ifconfig, by comparison, I'm going to do tcpdump. It's already installed on Kali Linux, and we see that the F0, not that much of an issue here because we're running tcpdump on the Ubuntu listening, but I just wanted to call that out one more time. Okay, with that said, we're going to target our Ubuntu machine, and we're using Kali Linux to do that. So we're going to use the nmap command, and there's a tutorial, as you know, in the video series. We're going to use nmap in an aggressive format. And what is the -A going to do? Aggressive mode means that it's going to give us operating system detection, what operating system this target machine is running. It'll give us the version detection. If there's any scripting engines, it'll do that, and a trace route as well. So let's go in reverse. Here's our trace route. It said it's 1 hop away, so it's very close, i.e. on the same network. So it says it's 1 hop away, so we know about that. We also can see that it is running Linux, and this is the OS operating system and the version 4X or 5X. And then it tells us some of the ports that are available. It tells us that SSH is available on this machine and port 80 is open on this machine. So we're going to go ahead and continue to verify that. So I'm going to now SSH, secure shell into that. So I'm going to SSH with my username to generate some traffic that we can capture. And if I slide this over just a little bit and bring the Ubuntu machine here, you can see that we're listening and you'll see this number over here start to change. So we're going to generate some SSH traffic, and it's going to ask me for the password. And now I'm in, right? And a couple of packets came in there. So I'm on the Ubuntu machine. Well, how do I know? One, my prompt here started as Kali, and now I am now at fmerin. Again, we have a tutorial on setting up an SSH server on your machine so you can remote shell into your device. Let's go ahead and do the Neo fetch on this here as well. So this is how I know I'm on the Ubuntu machine, pulling that experience into the Kali Linux terminal, because we used secure shell to get into it. So we SSH'd in that port 22, which Nmap told me it was open. And we're capturing all of this on the background. While we're there, we're going to, I'll just do a quick ls command. Now I'm going to close this SSH session. It's closed out, and now I'm back at Kali. The prompt changed from fmerin to Kali. If I do a host name here, you can see that I'm on the Kali machine. I'm going to bring this back on top. If I do an LSB release, this is going to give me the OS version, and it's Kali Linux 2024 Kali rolling. Again, we do all of these in previous lessons about how to install Kali Linux, how to run SSH servers. So all of that is more like review for this one here. So we have a little bit more work to do. I'm going to do a half open scan. So I'm going to use hping. Now, remember with hping, when we do any of these, that hping is considered an aggressive tool. So this is a tool that's going to do a packet crafting tool. So I'm going to, from Kali Linux, I'm going to do a half open scan, which is I'm only sending a SYN packet. If you remember, the full TCP3 handshake is a SYN, i.e. I ring the doorbell, I want to make a connection. The Windows 10 device says, hey, I hear you, I'll get to you, I acknowledge you, and then we say, great, we want to have a conversation, and we send an acknowledgement back. When we do a half open, it looks like this. A half open means that we ring the bell, the Windows 10 client server goes back to the client and says, hey, I hear you, I acknowledge you, and we never reply. This is a stealth scan, which is we're checking to see what ports are available, and we never acknowledge it. It's like ringing the doorbell, someone answers, and you run away. You know someone's home now at that point, and they just wait there waiting for you to come back. That's why it's called a half open. So we're going to Control-C, close that out. Again, all of this is being captured on the background here on our tcpdump because we need this information here. Okay, so we're back on this side. One more. Let's do a flood, a ping bomb, if you will. So I'm going to clear on the Kali side, and this time I'm going to flood the account. I'm going to flood the interface. So I'm going to do sudo hping 3. We could have done it that way. I'm going to back out the SYN, and now I'm going to throw a flood, which is we're going to do a denial of service attack on the interface. So let's just do this flood. So it's sudo hping 3, as you can see here. 172.16.1.102 is my Ubuntu machine, and I'm going to do a flood attack. And it says no replies are going to be shown. On the back end, I can see that the numbers are going up. And what are we doing here? We're basically sending packets to the interface of the Ubuntu machine. Which interface? The Ethernet interface. This card here that's plugged in. Now this obviously would be plugged in, and we're sending traffic into this interface. So that's what we're doing here on the Ubuntu machine on 172.16.1.102, and we're flooding that interface. This is considered an aggressive attack. It's a denial of service attack. We're overwhelming that interface. Okay, so we're done doing that. So we're going to Control-C here to stop. So we transmitted a fair number of packets into this interface. We also caught a lot of packets here because we were running tcpdump, running this command here. We're going to Control-C here, and now we have our packet. And we have our tcpdump. We're looking pretty good. And what were we doing here? Again, we're bring the file up here. We're running tcpdump on this interface. We're writing to a capture file and we want it super verbose. I don't need it. I'm using Control U. This is also in one of the tutorials, the Linux cheat sheet, so we can capture that. So first, let me see if I have that capture file. So we're going to do an ls capture. See, we do have that file. Let's clear, bring that up. We'll ls minus LAH, so we can see, actually just long, just so we can see the file size. We see it's a pretty sizable file. So let's see what that looks like. So let me do a little housekeeping on this side here, and then we're going to actually use tcpdump to actually see that capture dated. So we do tcpdump, and I'm going to use the -R to read and get that capture file. And we're going to actually look at that capture file in real time. So that took about 20 seconds, and as you can see here, it's going through all of the commands that we've worked with. This is our timestamps. It's not really that user-friendly in this regard. I'll do a little bit housekeeping on this end here. So let's take a look at it in Wireshark. So I'm going to clear the screen. I'm going to use Wireshark to see this. So we're going to use Wireshark, and I'm going to look at that capture file that we just created. So let's give that a moment to fire up our Wireshark. So Wireshark loaded up that capture, that pcap. Let's make this a little bit bigger. We're going to do a couple of things here. We're going to view. We'll change the time display format just to make sure. As you know, this is packet number 1. This was the network time protocol to get the latest version of time. This is an ARP request, and we start to see some of that TCP packet. And this is the Nmap scan that we started off with. So this is what we started off with. We can see it a little bit better. So you're probably wondering, if this is a TCP replay tutorial, why are we doing TCP dump? Well, for a couple of reasons. We need to capture a file. So I can go here into tshark dev setup, and I have it teed up over here. So in order to analyze a pcap file, we either have to generate a pcap file, or we have to capture our own, and that's what we did. So we captured. You can search additional pcap files. This is in the TCP dump tutorial, but we're starting from ground zero, generating our own traffic. So in this case here, we generated our own traffic. Now we have a pcap file. It's called pcap. Let's go here. It's called capture.pcap. It has 362 packets. We're displaying all of them. So we have all of our information that we need. So now we're ready to actually get into TCP replay. Okay, so what I'll do is I'll minimize Wireshark over here to get it out of the way. I'm going to actually close it out. We don't need it for the time being. And I'm actually going to replay that packet. In other words, we're going to take this capture file, or this pcap file, which is the pcap file that we have here, and we're going to play it right back onto the interface. So let's see how long that will take. So that didn't take too long. We did, it took about 10 seconds to take the files, and we got some information back. So out of all those files, only actual 2023 packets were replayed onto the interface. We have the speed of about 196 packets per second, and it gave us some stats here. We had a failed packet, successful, truncated packets, nothing was cut off. We didn't have any retried packets. In other words, there were no buffered, and we had no e-gains as well. Resource temporarily unavailable. So we're looking pretty good here, but this took a little while. So let's see if we can modify the speed. So we're at the speed side of it here. So we can specify the replay speed of that packet file. So I'll take this, copy it into clipboard, bring it over into the Ubuntu side, and we're going to replay this speed at, let's make it 10 megabits. We can do 1 megabit, but let's just make it a little bit faster and hit enter. And now we see this is a lot faster. We're generating this same data, but a lot faster. So we're running this at 4,923 packets per second, a lot faster than this version here. On that note, if we can go 10 megabits, let's go full wire speed, or as close to wire speed as possible. We'll go to top speed. So I'm going to do top speed, and let's see how long that takes us there, and we're good. So top speed, as you can see, is lightning fast, almost the same as the 10 megabits, because we know it was a 10 megabit Ethernet card or wire, and we still get the same information. So when you replay these packet files, you can replay them at a faster speed. It's like running a YouTube video or any other video on 2x, 3x, or 10x. So great, fantastic. So let's do a little housekeeping on this side here. And one more, we're going to filter and extract specific traffic. So I'm going to clear the screen here. As you know, we have our capture file sitting here, and inside that capture file is some SSH traffic. We may only want to replay SSH traffic. We don't have to run the entire file. So first thing we're going to do is get tcpdump. I'm going to copy that here. Again, you can copy and paste from the companion guide. My recommendation is that you type these when you're working with them. But for the purpose of the tutorial, I want to respect everyone's time. So I'm not typing because I'm not the greatest typist, but I can copy and paste a lot faster. So let's take a look at this command line. tcpdump, we're going to read this capture file, TCP and port 22. We know port 22 TCP is SSH. We're going to write that to a new file called SSH traffic pcap. It did that real fast. It created it. Let's take a quick look. Now, we can go into Wireshark and take a look at that traffic a little bit differently. So I'm going to just go into the applications side of it this time and go to Wireshark and then use it like any other application. As much as we like the GUI, we also like to use the command line. We could always use the GUI as well. So this is sitting right here on my home folder. There's the capture file. This is the SSH file we just pulled out, that we just created, and this is strictly SSH traffic. So if we needed to get SSH traffic, we can pull it out and then we can replay it using Tcpreplay, the point of this tutorial, and actually go ahead and run that basically recording. So I copied it, Tcpreplay, I'm going to run it on my interface, and it's the SSH cap. And let's see how long that takes. So as you can see, that took a long time. It took over a minute. It took about 70 seconds, 70.12 seconds. So when we're running them back, we may want to run them at full speed if we can. So I'm going to use this command and combine it two ways. So one, we're going to run this at top speed, but I'm also going to loop it 5 times. So I'm expecting to see all of these numbers 5x. So it's the same file, but we're going to run it at top speed. And we see everything is multiplied by 5. So failed packets went to 5. We had successful packets 170. If you multiply that by 5, it's 850. So we have some options here that we can speed this up. Now the whole point of this tutorial is to really set it up for future tutorials. The reason why we're here is we want to do TCP replay, so we can test intrusion detection effectiveness. So in future courses, we're going to install an intrusion detection system like Suricata that allows us to observe, protect, and adapt. And we're going to take capture files and replay them on the network to see if our IDS and IPS is working. And just to make sure that our IDS and IPS is working, we'll also install another IDS IPS, which is Snort. So Snort is an intrusion prevention system as well, and we need to test the effectiveness of them. So we need to have the TCP replay tool and get capture packet files, and we can get malicious capture packet files from different sources. We can generate our own, but we need a way of one, recording, which is the TCP dump portion of it, or we need TCP replay to replay either our own generated traffic or pcap files we have received from reliable sources or from other sources. Why do we do this? We want to simulate real-world attacks, and we want to look at network traffic and see how it behaves. So that's why we wanted to introduce this. It's more of a setup for future classes, but I thought it was necessary. And it's also part of, although a dated exam, the 601 CompTIA operations incident. You should be familiar with the TCP utility. So with that said, we got to the bottom of this, we got through it. If you want to get some more additional help and play around with tcpdump, TCP replay, I should say. I'm going to clear here, and you can get help from the traditional way. TCP replay, tac help is going to give you more information and more commands that's available here, and it gives us the ability to learn a little bit more about the utility. I'm going to clear for a second here, and you can also use the manual. TCP replay is going to give you the manual, and this is where you get the deeper dive or the documentation. So once again, this was a tease or a setup for future lessons, especially when we get into the intrusion detection systems and IPS. But I wanted to introduce this here. I hope you enjoyed this lesson. I look forward to seeing you in future lessons and hope you're having a great time with your cybersecurity journey. See you at the next lesson.